Hi everybody, I'd like to start today by rewinding back to yesterday and exploring some of the problems that I posed to you. I also want to look at the approaches you may have taken to solving those problems and the solutions that you arrived at. Okay, so we're going to start by looking at the first question, which asked you to tick the pair of numbers that had the biggest difference. You were given three options. The first option was -4 and 12. The second was -8 and 9, and the third was -20 and -11. So let's look at each one in turn and work out the difference, and then we can find out which has the largest or biggest difference. Okay, so over to my worked example. I've already had a go at this one. So firstly, I like to represent a problem mathematically. So when given it, rather than just trying to calculate everything in my head, I like to draw it out in a way that I know is familiar to me. And we've used number lines quite a lot when exploring negative numbers. So first, I plotted -4, I then plotted 12, and I knew that 0 was going to sit between both of those numbers. Okay, so next thing I thought is I know that trying to calculate -4 to 12 and that jump, the difference there, is going to be quite hard with all those different things to store in my head. So what I did is I did it in two stages. Remembering back to our counting on the number line yesterday, I started with 0 and I realised I could count forwards from 0 or I could count backwards from 0. So let's just start by exploring this way. So we start at 0 and count backwards. How many intervals do I cross when I count from 0 to -4? I know that that is 4. And I can ask the same question when counting forwards from 0 to 12. How many intervals do I cross when counting from 0 to 12? The answer is 12. What this very clearly shows then from my representation is that I have a difference of 16, and that's the calculated part. So once I have represented it, I can then calculate the difference. Now, that is not the end. Once I've got to that stage, I need to solve the problem. Now think, have we got enough information to solve the problem yet? No, because it asked us to compare the difference between three sets of values. So what I'm going to do is I'm going to look now to the second set. I haven't completed this one yet because I'd like you to pause the video and to use the same method or approach as I took to solving this, and then have a go here. Okay, so what I did is I counted backwards from 0 to -8, and I realised there was a difference there, if I can get my pen to not move, of 8. And then I counted forwards from 0 to 9 and realised there was a difference of 9. Now what you can then do, once we've represented it mathematically, is calculate it. So in total, I can see there the difference is 17, and I can record that at the side. And finally, I had the values of -20 and -11. Now I knew that my 0 would not sit this time between those two values, that it would instead sit after -11. So what I needed to do is focus my attention here. So I needed to count on or backwards, and I chose to count backwards as I had been doing from 0. So -11 to -20, what is the difference? The difference is 9. And I can record it at the side. So finally, what do we have to do? We have to solve it. So going back to my original question, I needed to tick the pair of numbers that had the biggest difference. And what did we decide? We decided that the biggest difference was B, and the difference was 17. So let's look at the next problem. It says this sequence increases by 7 each time. What are the missing numbers? So let's take note. We have something, -16, something, -2, something, something. So we know that each of these values has a difference of 7. We can confidently say that. So the first thing, if we remember, we need to represent it. So I'm thinking about how I can represent this mathematically, and I know that the number line is familiar to me. So I have started to draw my number line, and what you'll see is I've actually written down the sequence on a number line with the missing boxes. Okay, so I've also identified where I feel 0 will sit because it's helpful when counting through 0 to know exactly where it's going to be placed. Let's start with -2. The reason being is because it's the closest value to 0 that I know is familiar to me. And what I'm going to do is I'm going to start by counting backwards first, and we know that the difference between these two values is 7. We know the difference between every point on this number line is 7. So count back 7 from -2 will get us to what value? Hopefully you've said -9, so I'm just going to put that on there. Now we can check at this point, because if we are correct, we can count back 7 more, and we should be able to count back minus, I'm going to use my fingers, if you can see, -10, -11, -12, -13, -14, -15, -16. There is a difference of 7, I am correct. So again, I'm going to count backwards from -16, 7, and I am going to find that I get to what value? What value should I get to? You should have -23. I do apologise if that's very, very small for you to see. Okay, then we come to this tricky part, because we're counting through 0. Now, what strategy have we used here before? We have looked at counting backwards from 0. How do I get from 0 to -2? I count back 2. And then we can count forwards from 0. Now this problem is a little bit different to the one that we modelled before, because here we are looking to create a difference of 7, because we know the difference between -2 and this missing value here is 7. So how many more will I need to add or count on from 0 to create a difference of 7? Hopefully you can see that that answer is 5. So from -2 to get to this box, I have added 7. Now, what you will notice is that very clearly this highlights that this is 5 more than 0. So the answer is 5. Very easy when I've added my 0 in, or placed, should I say, my 0 on my number line. So then here, what I need to do is count on 7 more, and hopefully this should be more familiar to you, the answer being 12. So we can check that together. Okay, so let's whiz over to the next problem. It says another sequence decreases by the same amount each time. What are the missing numbers? Here we are given 19, missing value or something, 7 and something, -5 and something. So we first think, how can I represent that mathematically? And we are obviously going to use a number line. Now, just think back to the previous question, and if you have it in front of you, you'll be able to look. What's the same between these two problems that were posed, and what's different? Just pause the video here and have a think. What you should have been able to identify is that they're the same because we are being asked to find missing values within a sequence. But you should notice that it's different because here we were given the phrase that a sequence increases by 7 each time. So we knew the difference between each value on the number line was 7. Here, it did not say what the difference was. It instead said that a sequence decreases by the same amount. So all we know here is that the difference between each value on our number line is exactly the same. So we almost need to revert back to yesterday when we were trying to find the difference and how we could calculate that. So I picked two numbers on my number line. I'm going to make sure I choose positive integers because they're easier to work out the difference between them. So let's start. What's the difference between 7 and 19? Hopefully you have noticed that it is 12. Okay, 7, count on 12, we reach 19. So now what I need to focus on is the fact that two parts have a difference of 12. Okay, two parts make 12. So if we revert back to our thinking around the bar model and almost see the bar model within this number line, How can I calculate what one part is worth, or what the value or difference between two values on the number line is? You should be able to identify that each is 6. So that tells me, because each part is of equal, that each integer is of the value 6. So from here, what I can do is I can use my method of counting forwards or counting backwards. It's completely up to you what you feel most comfortable with. If I start with 7 and count on 6, I should arrive at 13. I can always check, because if I start at 19 and count back 6, I should arrive at 13. That was just my dog shaking in the background. Okay, now we know that the value of each integer is 6, so I can record that there. So if we start at 7 and we count back 6, we arrive at 1. And this is helping me to understand where my 0 fits on my number line. Around there. Okay, now we don't actually have to count through 0 here. Fortunately, we've been given the next value in the sequence. So we can simply start at -5, and we know the interval has a value of 6. So we can start at 5 and count back 6, and we arrive at -11. Hopefully you had achieved the same completed sequence as I have. So finally, for this question, it asked us to look at the 10th number in the sequence in part B. So we were here. Now remember, I have represented this slightly differently because this number line is familiar to me. But what do you notice about my sequence here? Hopefully you can see that it is recorded backwards. And when I say backwards, I mean it is recorded in the opposite way to how the question was posed. Therefore, this is the first number in my sequence on the question: 2nd, 3rd, 4th, 5th, 6th. Now, we want to find the 10th. Can you pause and think of the quickest way that we could find the 10th number in the sequence? You may have noticed that we need to calculate another 4 intervals. And therefore, if we know each interval is worth 6, we could actually count back 4 lots of 6. And if we start at -11 and count back 4 lots of 6, or count back 24, we should arrive at -35. Now, it's always helpful to check. So if you want to use the model of repeated, oh, come on, pen. If you want to use the model of repeated subtraction, you can start at -11 and you count back to -17, -23, -29 and -35. So the next problem asks us to look at a graph that displays the temperature of 6 cities on one day in January. So the first question asks us which city was 5 degrees Celsius warmer than Tallinn. So we can see Tallinn here. Now, what I need to do is, this is represented mathematically, so I need to start thinking, what do I notice about this? What can I tell you about the values of each of the different countries in degrees Celsius, or the temperature of them? So if we can look, Tallinn is -3. So what I'm going to do is create myself a small table, and I'm going to write down or record that Tallinn is -3 degrees Celsius. And it's helpful for me to refer to when I begin solving the problems. Let's have a look again at Moscow. I have -6. I'm just going to record that on my table. I can see that Rome is 6 degrees Celsius, if you can see where I'm looking, where the bar meets the axes. And that was Rome, 6 degrees Celsius. Oslo, in the minus temperatures, because the value is before 0. We count backwards from 0 to minus, what sits between -8 and -10? Hopefully you can see the value is -9 degrees Celsius for Oslo. London sits above 0, and we can see that that is 2 degrees Celsius. And finally, Athens, a lot warmer than London. We can see that is 10 degrees Celsius. So what I want to just quickly show you is how I've recorded that information just to help me. So Again, back to the question, it says, which city was 5 degrees Celsius warmer than Tallinn? So I'm looking for a difference of 5 degrees. So what I've done is I have used that information and I have plotted it or represented it mathematically. So -3 on my number line. I know that there is a difference of 5 because I want something that is 5 degrees warmer. And I know I must have to count through 0. So we're going to use our knowledge of how to do that. So I'm going to start. If I start from 0 and I count back to -3, I know there is a difference of 3. I've counted back 3. Now to create a difference of 5 degrees Celsius, think, what would I need to do to count on from 0? I would need to count on 2. 3 and 2 makes 5. So very clearly, now I've represented it, I can calculate very easily that the difference of 5 creates a new value of 2 degrees Celsius. So I'm looking for a city that is 2 degrees Celsius on that one day in January. So if I go back to here, I have already identified that London was 2 degrees Celsius. How easy is that, making the maths easy? So then go on to solve it. Which city was 5 degrees warmer than Tallinn? We should write London. So the next part asks us which 2 cities have a difference in temperature of 11 degrees Celsius. So how can I represent that? So again, I have my number line. I know that I'm looking for 2 cities that have a difference of 11 degrees. Now, how would you approach this? Just have a pause point and think, how could I approach this? Now, I can see that I'm probably going to have to count through 0 because there's not 2 negative values that have a difference of 11 degrees, and there is not 2 positive values that have a difference of 11 degrees. If I use this example, the lowest temperature that is a positive integer is 2 degrees Celsius, and the largest or biggest value is 10. They have a difference of 8. So I'm going to record 0 on my number line, meaning that I have to count backwards from 0 and forwards from 0 to create a difference of 11. So who can pick 2 values that they think might have a difference of 11? Let's use a bit of trial and error just to see how that might work. So we could try, for example, Tallinn, which would be -3, and we can try Rome, which would be 6. What we would notice is that if we count backwards from 0 to -3, we would have a difference of 3. And if we counted forwards to Rome of 6, that would be a difference of 6. 3 and 6 makes 9. So that does not have a difference of 11. Instead, I can see that Oslo is -9 degrees and London is 2 degrees. So let's check, because I'm feeling pretty confident about this one. If I count backwards from 0, I know that there is a difference of 9. And if I count forwards from 0, I can see a difference of 2. Now, don't worry about the fact that those the size of these intervals here looks very similar, because we're just doing rough jottings for now. But what we can see is that altogether there is a difference of 11. 9 and 2 makes 11. So I can confidently say that there are difference between -9 and 2 is 11. And we had -9 was Oslo and London was 2 degrees. So if we go to solve the problem and quickly revisit the question, which 2 cities have a difference in temperature of 11 degrees Celsius, we know that the answer is Oslo and London. Already on to question 4, we're absolutely flying through this. So we have a number line which shows a winter temperature and a summer temperature in Alaska. The difference between the temperatures is 48 degrees. That's massive, isn't it? That's a huge difference in temperature. So they want us to identify the 2 temperatures, the winter temperature in degrees Celsius and the summer temperature in degrees Celsius. So remember, what do we need to do first? They've already started to think about how we might represent it mathematically. So we go to our number line. Again, always thinking that because they've already told us the difference, we can also add that information to our number line. Now, I very carefully copied down all of the intervals on this number line and made sure I had the same number as that were in the question. So it's always important to be accurate. What I might have done is, if I had the practice book in front of me, was to actually use the number line that they provided for me. So I didn't make any human errors. Okay, so now I think you might see this is familiar to a problem that we solved yesterday. So again, it's using that idea of a bar model. So we are looking at the whole amount being 48, and we can say how many equal parts make our whole. Or we can say how many intervals make the whole amount. So if we start from here, we count on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 parts make the whole amount. So remember, how do I calculate just one? What do I have to do with 48? You should recognise you have to split it into 12 equal parts. And another way of splitting it is to divide it equally into 12 equal parts. Now, you should be able to use one of your multiplication facts to help you here. And we can recognise that something times 12 is 48. Hopefully, you are saying 4. So we know that each interval has a value of 4. And I could record that if I wanted to, just to help me, but each interval has a value of 4, just like we filled in our bar models yesterday. So this should help me in counting on from 0 and counting backwards from 0. So starting at 0, I want to know what temperature it would be in the summer. So let's fill it in and let's use our recall of our 4 times table. 4, 8, 12, 16 and 20, 24, 28. Sorry, I won't sing at you again. It's just a song that I remember. So we reached 28 degrees Celsius. Okay, we're going to do the same, but this time we're going to count back from 0. So our intervals or integers, each number, each value is going to be minus or a negative number. So we can do exactly the same again. We can count 4, 8, 12, 16 and 20. So this time we say negative or minus 20 degrees Celsius. And we can just have a look. We can check minus 20. If we count on to 0 or count back from 0, we know there is a difference of 20. I'm just going to mark that there so you can see. And here, if we count on from 0 or back from 28, we can see that there is a difference of 28. And now I've represented it like the problems that we've just visited. 20 and 28 has a difference, total difference of 48. Hopefully that makes sense to you. So here we have to work out the missing numbers on this number line. Now this is getting progressively more complex. Why? Because they haven't given you, like this question, the total difference between the two values that you're trying to identify. Here, it's very much like that sequence question, isn't it, where you've got to find the missing values. But you notice that even though the intervals that they've given you on the number line are equal, the space between each of the numbers in the sequence is not, however, equal. So we're going to have to use a slightly different method here to work this one out. What we do know is that this is minus 100 and that this is minus 20. So if we focus on what we know, we can use that to solve the rest of the problem. So what I'm going to do is I'm going to say here that the whole amount between, or the difference, let's use the correct terminology, between minus 20 and 100 is 80. And we can calculate that by counting back from minus 20 or counting on from minus 100. Now, what do you recognise? Think back to that bar model. How many parts is 80 split into? You should recognise it is split into 1, 2, 3, 4 parts. So as we did with this question, we are going to split this amount into 4 equal parts. Now in doing that, what is that going to tell us? Hopefully you recognise it tells us the value of each interval or each part on the number line. Again, there should be a known fact that we can use to help us here. So 8 divided by 4 is 2. So 8 tens divided by 4 is 2 tens. Or 80 divided by 4 is 20. So I can see quite confidently and label that each interval on my number line has the value of 20. This will help me. So if I start from minus 20, because I do not have to start my count at 0, I can count back a total of 40, or 20 and 20 more. Now remember, if we rephrase that as 2 tens, we can count back 2 more tens and 2 more tens. So 2, 4, 6, minus 60. And what I want to just do is to check that that successfully allows me to reach minus 100 on my count. So let's try that. So minus 60, minus 80, minus 100, or minus 6 tens, minus 8 tens, minus 10 tens, however you want to phrase it. Okay, just realised I've had my finger over the camera for the last 5 minutes, I do apologise. So here we are. Now we don't want to count back from minus 20 this time, we need to count on. So remember, this interval has the value of 20. This seems to me quite simplistic because what we can see here is that something count back 20 is minus 20. And if we have our knowledge of the number line, we know that this value must be 0. Okay, so again, I like to count on from 0 rather than counting through 0 because it allows me to calculate very effectively. So I'm going to start here and I'm going to count in my intervals of 20, 20, 40, 60. Hopefully you found the same solutions. Now, this is one that I saw everybody becoming increasingly frustrated with on Google Classroom. So what I'd like to do is provide you with a worked example of mine so you can see how I approach this problem. So first, let's read it together. We had to arrange the numbers in the diagram so that the difference between pairs joined by a horizontal line, so first we must know that the horizontal line goes across from left to right, is 16. And the difference between pairs joined by a dotted vertical line, which goes from top to bottom, is 9. So I know that it's already given me 2 pieces of information that I need to record on this diagram if I am going to find that helpful at all. So I have done that very clearly here. So I've marked that the difference between those 2 values is 16, and the difference between those that are sat top and bottom to each other are 9. That is going to be helpful when I come to filling this diagram model in. So then what I did is I decided to record the numbers that were presented to me on a number line. So we were given minus 20. We were given minus 13, minus 11, minus 4, 3 and 5. We weren't, however, given 0. But we know that it is important to include it so that we can count backwards from 0 and forwards from 0. So what I started by doing is finding out all the pairs of numbers that had a difference of 9. And you can see that I've done that and I have highlighted that in green. So from minus 20 to minus 11, or I can count from minus 11 back to minus 20. I should see and recognise there is a difference of 9. Can you see how I've done that with the others? So then what have I done with these orange lines? Try and explain that very quickly with the person that's next to you, or simply write some jottings. So what you'll have noticed is that then I was looking to find a difference of 16 and all the pairs of numbers that had a difference of 16. And I've done that by connecting them with an orange highlighter. So now that I had my patterns, I could start to make sense of this diagram. So what do I notice about these numbers? I notice that 20 has a pair with a difference of 9 and another pair with a difference of 16. I can say the same for 13, 11, 4. What about 3? Say the same for 5, but 3 doesn't have another pair with a difference of 9. So it almost needs to be one of these end values. So it doesn't matter whether I put it at the top or at the bottom, but I know that I can start with 3 because it only connects to minus 13 with a difference of 16. So it doesn't matter which way I record it, but I'm going to do that very quickly now. I'm going to choose a red pen, do apologise. So I'm going to start by filling in 3, which is connected to minus 13. They have a difference of 16. Next, I need to look for a difference of 9, but I have to start with minus 13. So I coloured it, colour coordinated, in green. So I know that minus 13 is connected to minus 4. So I'm going to record that. Then, starting from minus 4 this time, I know I'm looking for the number that has a difference of 16. So minus 4 and minus 20 have a difference of 16. Then, starting with minus 20, looking for my green line now because I'm looking for a difference of 9. I know that minus 20 and minus 11 have a difference of 9. And finally, starting with minus 11, I'm going to find what value joins together with it because they have a difference of 6. And I know the answer is 5. And I can work backwards from 5 and just see if my solution is correct. But what you can see is I worked through that systematically. Wow, yes, it was definitely magic. Systematically and logically. And I didn't just use trial and error. The best mathematicians do the easiest maths and make it easy for themselves. Just remember that. Okay. The final thing I'd like you to do is to completely reflect now that you've reflected on your learning. And I would like you to complete the task that I've set for you on Haggerty. I'm going to be around all day if you want to chat about anything or if you want me to film any more videos to model my approaches that I took to solve the given problems. Okay, bye-bye for now, guys.